Okay, hi students. So we are now continuing our lesson with natural polymers. Okay. Now, when we talk about natural polymers, first of all, polymers are large molecules with many smaller identical repeated units of monomers. Okay. So monomer is a smaller unit, okay, individual unit, what we call as a monomer, whereas a combination of monomers forms a polymer. Okay, so polymers are repeated units of monomers. All right. Now, when we have a monomer which combines to convert into a polymer, the process is called polymerization. Okay, so polymerization. Right. So polymerization can be defined as the process that combines monomers to form a long polymer chain. Right. Now, if we reverse that process, polymer to monomer, okay, it is called depolymerization, the reverse process. Okay, so this is depolymerization. All right. Okay, now let's look at some examples of monomer and its polymer. So, one example of monomer is ethene. All right, ethene, the polymer or combination of a few ethene forms polyethylene. Okay, polyethylene. Okay, similarly, another example would be styrene, which combination of styrene molecules will form a polymer which is called polystyrene. Okay. Okay. Next we're going to look at something called PVC. Okay, I think you all are quite familiar with PVC used in pipes. All right. So PVC is from a monomer which is called vinyl chloride. Okay, vinyl chloride. Okay, the combination of this monomer will form polyvinyl chloride. Polyvinyl chloride, right? And that is what we name as PVC. Okay, this is PVC in short. Okay, the fourth example would be methyl methacrylate. Okay, methyl methacrylate. Okay, this combination is going to be polymethyl methacrylate, or in short we call as perspex. Okay, this is polymethyl methacrylate, which we call as perspex. Okay, so these are four examples. All right, monomer and polymer. All right, maybe if we can add one more, rubber. Okay, rubber, the monomer is called isoprene, so just add one more here. Okay, isoprene is the monomer for rubber, because we're going to take a look at rubber. Right? Isoprene is the monomer. Polymer is called natural rubber. Okay, natural rubber, or sometimes we call it as latex. Okay, next, when we talk about polymer, we already know polymer is a combination of molecules, smaller molecules, which are called monomers. All right, polymer is a bigger chain of molecules. So polymer itself can be divided into two types, two categories: natural polymer and synthetic polymer. Okay, now For natural polymer, some examples, right? Some examples would be rubber. Okay, that's a popular one. Starch. Okay, starch is a polymer. Monomer would be glucose. Combination of glucose becomes starch. All right. Rubber, we already know the monomer is isoprene. Combination becomes rubber molecules. All right. Other examples under natural polymer would be cotton and silk. Okay, so cotton and silk. All right, if you find more, you can add it in here under examples. Now, synthetic polymer example, PVC, as we talked about just now. PVC, polyvinyl chloride. Okay. Synthetic rubber, nylon, and also perspex. Okay, so these are all examples for natural polymers and also synthetic polymers. Okay, now we're going to look at polymerization and depolymerization of perspex. Now, we talked about perspex just now. It is actually coming under synthetic polymer. So, under synthetic polymer, we will take a look at perspex. For natural polymer, we will look at rubber, natural rubber, right? Okay, so first of all, we are going to look at polymerization process. Okay, so this process is called polymerization. All right. So we already talked about polymerization is when monomers combine to become a polymer. So an example, if we take a monomer, okay, monomer of perspex, it will become a polymer of perspex. All right. Now for polymerization, there's a few characteristics or few requirements. One is we need a catalyst. Okay. So catalyst for this particular polymerization of perspex, we are using lauryl peroxide. Okay. So lauryl peroxide is the catalyst which we will use in this particular reaction. So lauryl, let me write it here, LAUROIL peroxide. Right? So this is the catalyst. So you already know what is a catalyst from our previous chapters. Catalyst is used to make the reaction faster. Okay. So in this case, to form perspex at a much faster rate. Okay, these apparatus involve a beaker. Okay, and it's heated up to 80 degrees, 50 to 80 degrees. Okay, and lauryl peroxide is mixed with monomer, which is perspex, and we will actually get the reaction product will be produced in the test tube, and it is cooled down until a transparent solid is formed. So the transparent solid which is going to be formed here is going to be the perspex, okay, which is formed. So remember, for polymerization of perspex involves perspex monomer, and it is added with lauryl peroxide, okay, as a catalyst, and the temperature is taken from 50 degrees Celsius right up to 80 degrees Celsius, and the polymerization reaction will produce a solid here, okay, which will be perspex polymer. So this is the perspex polymer. All right. Now, if we do depolymerization, that means we're going to reverse this reaction. Okay, depolymerization will involve just heating. Okay, just heating of perspex. So here we have perspex chips. Okay, placed in the test tube, heated up. All right, and when the solid melts, okay, it disintegrates into vapor form, and this mixture of this mixture of water and ice, okay, you can see here water and ice, is actually used to condense the perspex monomer vapor back into liquid monomers. You see, when perspex actually is heated, it will become, let me write it here, this will evaporate. Okay, this will evaporate into this thing called perspex monomer. Okay, when you heat up, the polymer becomes monomer, it breaks. Perspex monomer, and it is actually in vapor, so vapor. Alright, and when this vapor comes down the test tube, alright, because we have a combination of ice and water, it cools down. Okay, it cools down, therefore in this section condensation happens, and the perspex monomer vapor will solidify, it will become solid. Alright, so that is actually the product you get as a perspex monomer.